In this video, I'm going to talk about how to balance half reactions in redox chemical reactions. And so if you want to balance a redox reaction, it's much easier to balance the reduction half and then the oxidation half, and then set the number of electrons lost equal the number gained, and add up the two half reactions to get the overall whole reaction. And the reason you need to do this is because there are other things that are actually not written in the equation that you're given. So for example, if you're asked to balance the reaction of iron 2 with hydrogen peroxide to form iron 3 in water, there are some things you need to know about the environment. Is it an acidic environment or is it a basic environment? So we're going to balance this in acid. And if it's in acid, that means we can add H plus as needed or water as needed to balance the hydrogens and oxygens. Okay, but you don't want to do that first. First thing you have to do is figure out exactly how many electrons are being transferred. So when you look at the oxidation numbers, peroxide, the oxygen is -1. Usually oxygen is -2, such as oxygen in water. So if we have two oxygen atoms here, each of -1, they each need 2 electrons to get changed to 2 oxygen atoms of -2. So we're going to require 2 electrons to be added. So remember, reduction is gaining, so these oxygens are gaining electrons. Now we balance the elements. Okay, so we balance the oxygens. So we say, okay, there's 2 here. And now we balance the hydrogens. Okay, and there's 4 hydrogens here and there's 2 hydrogens here. And so in acid, you can add 2 more H pluses without affecting the overall coefficients of all the other parts. Now after you do that, then the total charge should be the same on both sides of the half reaction. So you can see that we have 2 negatives and 2 positives, and we have a total of 0 over here. So this is balanced. Okay, now the other half reaction is really trivial. If you go from iron 2 to iron 3, you have to lose 1 electron to do that. All right. So this is the oxidation half reaction. So the reduction requires 2 electrons. The oxidation only gives 1 electron. So we have to double the number of times that you run this half reaction in order to get the 2 electrons you need for this. So we're just going to put 2's out front. 2, 2, and 2. Now we're going to add this half reaction to that half reaction to get the overall reaction, which will be H2O2 plus 2H plus. These are all aqueous ions and molecules. Okay, that's those 2 plus 2 irons. Goes to 2 waters plus 2 iron 3s. And that's it. Okay, so what we're going to do is check the overall reaction at the end. Okay, so we have a total of 2 pluses and 4. We have a total of 6 plus here. So the total charge is okay. Now we're going to count hydrogens. 1, 2, 3, 4. There's 4 hydrogens. Number of oxygens, 2. 2 oxygens, and then the total number of irons is 2 and 2. So this is how you balance the half reactions in order to get the balanced overall reactions. If you're already given the balanced half reactions, this process is of course a whole lot easier, and you'll find most of those in the table in the back of the book. The other thing I want to mention is if it's in base, the requirement's a little bit different. In this video, I'm going to talk about balancing half reactions in base solution. There's a couple of different ways you're going to do it. One is we're going to balance the half reactions in acid first, and so that's step one. See the previous video on how to do that. So the example we had has this particular overall balanced equation. So if you're going to balance this in base, what you do is you neutralize all the acidic protons. So you add 2 hydroxides to react with these 2 H pluses, and you have to add 2 hydroxides over here. All right, and now we're going to say, okay, these 2 react to give me water. So after that is done, they're going to have H2O2 plus 2 waters plus 2 irons, iron 2s, goes to 2 waters plus 2 iron 3s plus 2 hydroxides. And then we note that we have waters on both sides, so we more or less erase. And of course, if you don't have equal numbers of waters, you have to subtract them from both sides until you do have this water on one side or the other. So let's look at this overall reaction. Charge of 4 plus and an overall charge of 6 plus and 2 minuses, which is 4 plus. 2 hydrogens, 2 hydrogens, 2 oxygens, 2 oxygens, 2 irons, 2 irons. All right, so it's as simple as that.